All right, guys, welcome to the last section of Statistics 7.6, sample means, sample proportions, confidence intervals, margin of errors. This is the nitty-gritty of statistics. This is what it all comes down to. We've been talking about a lot of things this chapter, everything from how to take statistics, what can you do with sampling methods, what does it mean to calculate a mean and a standard deviation, to what can we do with those, right? Is it a normal curve? Is it more of a binomial situation? Now we actually get down to what we were talking about the very first day. Do we actually get to say this is worth it? Okay. In 7.3, I did mention the big ticket item in statistics is, does your statistics really represent the actual population? That is the question now. We're going to look at a couple things. They all kind of center around the same formula. Or same two formulas. So go ahead, zip down to page 24 just so you can look at these real fast. They are crazy looking. Okay, I will let you know. Don't panic over them yet. These are what they look like. But what this is, it breaks down into three parts. Basically, how off are you? How confident that even though you're off, are you still right? And how does that where is really the average you're looking for, or the percent you're looking for, okay? So let's just start with the first one. We're going to come back to these formulas a lot. So go ahead and put a star by it. Okay, we will also be using this box right here a lot, back on page 23, but that is also in another spot, so I'm going to have you don't have to box that one, okay? So I'm going to show you where to find that. But this box right here for confidence intervals on page 24, you're going to want to make sure you look at both of those. But all of this stuff makes much more sense when you're actually looking at an example. So let's head on over to page 25 and just dive right in. All right, page 25. A study of miles per gallon of vehicles owned by 38 drivers under the age of 28 shows that the mean, is 29.4 miles per gallon at the standard deviation of 3.6 miles per gallon. Find a 96% confidence interval for the average miles per gallon of these drivers. A lot of information here. Okay, it shouldn't be things that sound totally new, right? The confidence interval, definitely, but miles per gallon, hopefully you know what that is. Mean, we've been talking a crazy amount about. Standard deviation, we've been talking about. Sample size, 38 drivers. We even got the ages of those drivers, though we don't really need it. Let's kind of write down more in our notation what we already know, okay? We are dealing with statistics parameters. These are not solidified as right yet, so we are going to call them X bar and S. X bar was our mean, and standard deviation was 3.6, right? Those are what we had. If you wanted to kind of put them in parentheses as mu and sigma, you could, but we're not saying those are mu and sigma. We're saying that's what we hope they are, okay? And here's where we get into our confidence thing. Oh, sorry, we should also put down that N, sample size, was 38. Excuse me. That's all we've been told. Now they want us to come up with 96% confidence interval. Well, in statistics, there are levels to being right, okay? 100% is impossible. You cannot be 100% right, okay? If you are, then you are a wizard, all right? 96, 98 is usually where we want to be. All right. If I go back to that other box, you can see some kind of areas that people tend to be confident. 50%, you're really not confident at all. You're not really assuming that your study is worth anything. Okay, you're kind of just saying, I could be right, whatever. 80% is kind of the minimum people usually go with before they start publishing stuff. 90% is better. 95% is awesome. 95, 96, 98 is usually where you see people comfortable claiming, like, yeah, my study's awesome. 99, he's pretty kind of, nose in the air, I'm better than everyone. But, some people are. They get like this huge sample size. Choosing one of these for your study comes out of your sample size. The higher you can go, the more people you can actually ask, the better your data is. If you ask 10 people, you're probably shooting at a 50%. You ask 100 million people, you're probably a 98. Okay, and it depends on what you're going with, right? If you're looking at the population of the high school, obviously it's not 100 million people, but the more people you ask, the more confident you can be. Okay, we're going to come back to what this critical value thing is in a minute, but it's basically asking us, in this problem, find a 96% confidence interval. You need to be 96% sure. Luckily, that's not a personal note. That actually means something. 96% confident means I'm going to go back to that table and I'm going to steal that z value, okay? This is the same z that is in z-score. When we were dealing with this data, see, you saw that it was mean, right? So we're looking at a 96%. We're like looking at 2 standard deviations. We want to know with that level of confidence, okay? So we're going to borrow that z-score. Because it's 96%, it's a different kind of z-score. It's called a critical value. You're not going to find this z-score in your z-table, but it's a critical value. It's a zc. Same idea, though. It's a standard deviation mark. That would be 2.05. And that number does not change. Okay, every time you are 96% confident, your critical value is 2.05. Okay. All right. Here's where it gets a little not mathy. Let's say that, because I'm not sure what exactly it would be, but like ambiguous isn't even a good enough word. I'm going to say that 29.4 is not good enough to say it's exactly the mean. Okay, it's good enough for my data. For those 38 it is. But for everybody, I'm not that confident. I'm not 100% confident. I'm pretty confident, though, that it's somewhere around there. Right, so I'm going to draw a little picture over here. Here's that 29.4 on a number line. Okay, an interval means like a range. So I want to say, what is the range that I'm really confident about here, okay? I'm going to pick, sorry, I'm just going to fix my 4. Somewhere around here. It's like somewhere around here, okay? It's like somewhere in between there. Could be like 29 to 30. It could be 28 to 32. 96 is going to tell me how much I should shrink my interval by, but that's what I'm saying. The interval part of this is I'm saying it's kind of this ballpark, right? What we're going to do is actually find these 2 numbers that are sitting on the end. We're going to use that formula you boxed to do that. Okay, we're going to say we're 100% confident that it's in between these 2 numbers, not exactly the number we got. Okay, so let's find those 2 numbers. We'll see what we're talking about. The formula itself for confidence interval is x bar plus or minus cz s over square root of n. Now, if you look at those, you're like, what the crap? That was gibberish. Well, was it? We have all of those things, right? So we're just going to plug in all of those things. Let's go plug in all those things. So our confidence interval is going to be 29.4 plus or minus, let's see, the critical value right here, 2.05, times the 3.6 of our s over the square root of our 38. Yeah, it's not much prettier, but at least all of the variables are gone, right? The variables are gone. They're not there. So this is our confidence interval. Just kidding. That's not a number. That is an equation. So let's plug those into a calculator. We're going to plug in a plus version and a minus version. So we're going to do 20. Let's just make our life easier. Let's find this number, and then we'll both add and subtract it, okay? So 2.05 times parentheses 3.6 divided by square root 38, close parentheses. All right, so that whole thing is 1.197. We'll go to 3 for some reason. All right, so now we're going to both add and subtract that to the 29.4. So what is this 1.9 number? Basically, we're saying right here, that's our 1.197. 1.197. It's a standard deviation. It's a weird standard deviation, but for 96% confidence, that's what we're saying. We're going to say 1.97 in either direction. What's that going to give us? That's going to give us, if we subtract it, 29.4, then we're saying about 28.2 all the way through. We add it to the other side. 29.4 plus 1.197. 30.5. All right, and so over here in our confidence interval, it's from 28.2 to 30.5. That's where we're super confident that the real mean actually is. In our data, it was 29.4. But the real one, the real miles per gallon on vehicles owned, is somewhere in between 28.2 and 30.5. We are 96% confident about that. Okay. Technically speaking, that is usually how you will see it written, because statisticians like myself are super lazy. We don't like to split it up and actually add and subtract. I couldn't tell you why. We're just really lazy. So you might see it as plus or minus the back number, but it says the same thing, right? It says, well, it's this, give or take that. Okay, it's 29.4, give or take about 2, right? That's usually how you'd see people say it too. It's like, well, I usually get somewhere between, I usually get like 28 miles per gallon, give or take a mile or two. Right? And that's usually how you say it. So that's usually how we write it too. You can also hear people say, well, it's like 28 to 30. So you can, it's definitely a range in both cases, but usually you'd see the top one. Now, the other pieces here, each of these pieces has their own point, and that's what we're going to talk about next. But that is a huge claim on statistics. You are taking a statistic set, you're taking actual data that you have conducted a study for, and you're using it to make a very large claim about other vehicles. So if I was doing this for our classroom, I would use this for our classroom. I would say, all right, you guys scored like 79%, give or take 5%. I'm pretty sure that's like a 96%. 96% that's confident. It's a pretty good sample size. Does that mean our next 4 tests are going to go the same way? Yeah, I'm pretty sure about that. I'm pretty sure they're going to be between these 2 intervals, right? I'm pretty sure that because of this one, the next one's going to be, or even, actually, no, that's not exactly what I'm saying. Because of all that data, I could say that the other classes, all of the other secondary 3 classes will have around those same scores, right? Is it going to be exactly the 79% that this class got? No, but it's going to be give or take a couple percents, right? A couple decimal, or a couple 1%. So that's kind of what we're saying. We're saying confidence interval, give or take this, but it's much more accurate than just saying, well, let's look at a couple. Oh, there's my son, just in case. Fun fact. Again, I'm on my phone, so you got to see my son. Let's look at a couple of these pieces now. So we're going to look at what we call the MO, the margin of error, and also these sample, the standard error. And we're going to look at this in the same context, but also for percent things as well, for binomial things as well. So let's go on to number 2. Number 2, we have a random sample of 800 members of the AARP show that 429 of them buy products sponsored by AARP. For a 95% confidence interval, find the margin of error for the sample proportion. This doesn't sound like it would be anything similar, okay? But let's start with the confidence interval equation. Then you can also throw back to the margin of error equation. Take a look at that margin of error equation, and then take a look at the formula we just used. The margin of error is just the back half of that equation. The margin of error in our last problem was 1.197. That's another way to say it. That's what it's off by, okay? So this question is asking, what is it off by? Be 95% confident and tell me what this is really off by, okay? It didn't give us a mean or a standard deviation or anything like that. What it gave us was an out of. So let's kind of calculate a percent first. Let's figure out what does that actually mean? 429 out of the 800. Well, 429 out of 800, that's 53.6%. Well, that's not an average either. That's a percent. Luckily, we have a percent version of this equation as well. So let's go take the back half of this percent guy. Okay, so this is the percent version of the confidence interval. We're going to take the back half of it. That's going to be our MO. So here's our MO. It's going to be plus or minus the critical value. And then instead of the S over N, we're going to have a very large square root, P, and then 1 minus P over N. So it's still over N. We're still dividing by that N each time. It's just this time we're kind of doing the binomial idea of the pass and fail. Okay, so it's not the standard deviation, it's the pass and fail. Same thing, just adapted a little bit. All right, let's plug in our numbers that we know. We know the percent is, whoops. The percent was 53.6, so we'll put that in as 0.536. What was 1 minus that? Oh, so the fail would be 0.46 for 1 minus that percent. Okay? So that's how we get the top two numbers. Sample size, well, random sample of 800 members. Looks like that sample size is 800. Sample size is 800. Alrighty, that same ZC is the same idea as with the confidence interval totally or confidence interval for X bar. So we're going to go back to that table now. By the way, that table for you is also on the bottom down here. So that last thing, we looked at the Z table at the very beginning of the chapter. That confidence level Z table chart's now the last thing on page 28. So you can keep flipping back and forth to that one as well. For 95, it was 1.96. So we'll go up to the critical value here. For 95, we need to put in here a 1.96. Pardon me, we should have a plus or minus. All right, and we filled out all the variables. So critical value from the table, the percent from what they told me, 53.6%. The opposite of that, 46.4%. The sample of 800. We plug in all those pieces. We can figure this out. So let's go ahead and calculate that now. 1.96 times, parentheses, a very large square root of 0.536 times 0.464, all divided by 800. Oops. $0.345. Plus or minus 0.3, well, actually, we'd round to 346. So what the heck do we just find? We found that we're saying it's 53.6%, give or take about 3%. Okay? Give or take about, 0.3. So give or take about 3.46%. Right, and we're not saying give or take 3% because that's not very accurate. We're saying 3.46%. Give or take that, you're within 95% confident. Okay? The entire confidence interval would be 53.6 plus or minus 0.0346. So you can see how it just automatically flows into the next part. You are going to have to remember which piece is called what, but the margin of error, the range of error, plus or minus what you're off by. Right? That's a good way to remember that. How confident are you? That's the confidence interval, right? The whole thing. All right, let's do another one. A recent survey of voters shows that out of 296 eligible voters, the incumbent candidate is favored. Incumbent just means, I don't really know what it means. It means the one I think favored, the one that may already be in office, is favored by 48% of voters compared to the other candidate. Actually, somebody asked Mr. Schilling about that. I would really like to know. For a 96% level of confidence, find the margin of error for the sample proportion. So this is almost virtually identical to the last problem. The only thing they did was be nice and gave us the percent. Okay, so we got to find the margin of error with a 96% confidence. All right, we're going to need some pieces. So 0.48, that's going to be our P, right? That's our percent. So what's 1 minus P? Oops. Yep, 52. It's going to be our 1 minus P, right? 52%. Okay, we got those two pieces. Sample size, we're going to need our N. That was, 296. And then the only other thing we need was that confidence interval, that confidence value, that critical value. Let's go check out what 96% would be. 96%, that would be, 2.05, just like the first time we used 96%. So this would be 2.05. Therefore, our MO would be plus or minus 2.05 square root, giant square root, 0.48, 0.52 over 296. Okie dokie. Let the calculator handle it from here. 2.05 times square root 0.48 times 0.52 divided by 296. We're looking at plus or minus 0.05, 060 if we round. So about 6%. Right, we're looking at 6%, plus or minus 6%. That's our margin of error. Cool. All right, let's go back to finding entire confidence intervals now. Now that we're dealing with proportions a little more, let's try an entire confidence interval. So, number 4, a new emissions test conducted on a total of 215 cars found that and trucks found that 79% of vehicles met the minimum requirements. That's good. Find a 98% confidence interval. You are 98% sure that for a proportion of vehicles that meets the minimum requirement addition. So, let's be 98% positive here. That gives me a z-score, or a critical value, of 2.58. 2.58. All right, that's the first thing we got. The 79% was our P. And therefore our 1 minus P would have been 21%. Our sample size is the only other thing we need, 215 cars. If they don't give us one of those pieces, we can't be that confident. We can't produce a confidence interval, right? We can't fill this whole thing out. So you're going to have all those pieces there. All right, so the confident interval for this, well, in the first one, we put X bar in front. I think for this one, we're going to put P in front, right? Yes. For this one, we would put P in front. So this one, it's going to be our percent plus or minus our mo, right? We're going to plus or minus our margin of error. So percent was, 79. We do everything in decimals with the confidence interval, so 79.79 plus or minus critical value, right? We're that confident. There's our standard deviation line. And then a giant parentheses, square root, 0.79, 0.21 over the 215. We'll let the calculator handle this back half for us. Square root 0.79 times 0.21 all divided by 215. So 0.79 plus or minus 0.072. Okay, what does that mean? That means that we are 98% confident that the true percent, right, because this is just the ones we tested, this is just the 215 cars, but for all of them, we are 98% confident it's going to be between 79 minus 7.2%, or 71.8, and 79 plus 7.2%, 86.2. So the real average, the real percent that's going to meet these requirements, somewhere between 71.8 and 8.62, or 86.2. Okay, but we're lazy, so we'll just keep it like that. Questions? I guess you can't answer them. Ask the sub if you have them. Ask the sub if you have questions. Alrighty. The only one we haven't talked about is something called the standard error of proportion, or the standard error of the mean. We're going to look at that in the last problem. Okay, so the last problem doesn't actually ask for it, but we're gonna use it. We're gonna look at it as well. So we're gonna stay on this problem for quite a while. A survey of 250 high school males shows an average IQ of 96%. Okay, with a standard deviation of 5, assuming an 80% confidence level, so not really all that confident. Find the confident interval for a mean IQ of all the high school males in the school district. All right. We're going to first find the standard margin of error, because it's another piece of this. It's what you really are off by. It's what you're off by. That's what it is. It's nothing to do with your confidence. It has no part of your confidence. The standard margin of error, you don't have to flip back. You can just look at the video real fast. It goes all the way up at the beginning. For a average, it's this part. The standard error of the mean, also is it called, standard error of the mean, S over root n. That sounds familiar. That's part of our confidence interval. Same thing over here. The standard error of the proportion. Wait, we've done that 4 times today, right? But notice there's no critical value. There's no critical value on how confident you are. There's no 96%. So this part is just literally how off are you? Really, what are you off by? Then on top of that, how much do you feel off by, right? How much are you confident? So let's first find the standard margin. I'm sorry, not margin of error, because that's the MO. My apologies if you're working in pen. Just kidding. Standard error of the mean is what it's called. So the SEM. Let's find the SEM, the standard error of the mean. As you saw, there's also one for proportion. Okay. But we did this. We've done it 4 times, right? We've found the standard error. It's just before we go multiplying it by the critical value. So what is the standard error of the mean for this problem? S over square root of n. Well, wait, what's S and what's n? Oh, yeah, S was standard deviation, 5, over the square root of n, the number of people, 250. We are off by 5 divided by square root of 250, 0.316. That is the standard error. No plus or minus necessary. That is what we are actually off by. Okay, now how confident we are on that is going to help us build a confidence interval, right? We're going to rope this into the other pieces. But if they ask, that's the standard error of the mean. In this last problem, the standard error of proportion, 0.79 times 0.21, all divided by 215, square root that, it was about 2%. This part right here was 0.027. Just going to rewrite that real fast. 0.027 or 28, pardon me. That's how much we were off by. Then we coupled that with a confidence interval of 98, and we got the rest of the confidence interval. So either way you can calculate, no matter whether you're given a proportion or a mean. But that's what we have here. So now we can just plug that into our whole confidence interval, 80%. 96 was the, I'm sorry, let's write out the whole equation again. X bar plus or minus the CZ, oops, S over square root of n is the whole formula. We already found that. It's 0.316. Confidence level of 80%. That one I haven't used a lot, so let's go ahead and go down. Oh, 1.28. Okay, 1.28. And our X bar, our mean, was 96. Okay, let's kind of clean that part up a little bit. 96 plus or minus 0.40, 0.40. And if we even wanted to go a little bit farther, we would say, here's that 96. We're 80% sure that it's between 96.4 and 95.6. Okay, that's where we're actually 80% sure it's between. I'm going to clean up those numbers. Sorry, guys. My hand is starting to shake because it's almost lunchtime. 96.4. Okay, we're 80% sure it's between these. All right, we've answered the question. What if it wasn't 80, though? Like, how would this change if we were more confident? Would it get bigger or smaller? Interesting question. I like that we did the standard error of the mean first, because now we can just change out that z-value. Let's change out that z-value real fast. Let's be a little more confident. Let's say 98%. What if we were more confident? Let's go down and find 98%. 98% would be, you can't see, 2.33. What if it was 2.33% instead? What would we get? We would get 96 plus or minus 2.646. Or in other words, from 93.4 to 98.6. Notice our interval just grew a lot, right? We're only 80% sure it was that close, but we're much more confident if it's a bigger range, which makes sense, right? I'm not saying I'm more confident of that number. I'm more confident that I hit it. right? As the interval is bigger, I'm more confident that I actually found the real one, right? If I have more range in there, I am a little more comfortable saying that it's somewhere in there. If I'm really, really close to that average, I'm not really that comfortable saying I'm right, right? So the smaller percents, the smaller z-values, and the smaller z-values, the smaller the interval. And so we're actually going to get bigger intervals out of more confidence. 100% interval would be the entire number line. Right, we're not sure at all. It's somewhere there. We know it's there. That's pretty much all we got, right? And then we're going to be pretty sure about that. So I'm not saying I'm confident of my study. I'm confident that within that range, it's somewhere there. Yeah, it's kind of like the coward's way out, right? Like, oh, it's somewhere there. It's around there somewhere. You guys do this on your test all the time. Like, well, it's something like that one. It could be, because that sounds close, right? And you're pretty confident it's around that one. That's kind of the same statement we're making, which I find super funny. But you can just kind of illustrating the point of the z-value on this last part here. All right, before we officially break, this part, you got your sem. You add that on there, you got your mo. You add on the whole thing, you got your CI. Do you see how you really only have to memorize one part of this? But each part is saying something different. Standard error, how much are you actually off? Critical value, how comfortable are you being off? And then you're now going to build an interval out of that to show where you truly think it is. Okay, that's your confidence interval. This is the basis of statistics. So if you're kind of jiving with this, you may want to try a statistics course in college. No matter what, you definitely want to memorize this because we got a test coming up. So that is the end of the notes. As I've mentioned, these are posted to Canvas as well, so if you missed something, you can go back. But work on your homework now. I'll see you again next chapter.